Alright, this video is on stoichiometry. Stoichiometry is a branch of chemistry that deals with the relative quantities of species in a balanced chemical reaction. For example, we have the Haber-Bosch process, which is ammonia, NH3, is produced from hydrogen and nitrogen gases. I have the balanced chemical equation already listed below. Okay, now we've already done some problems with molar ratios, and we understand what those coefficients mean. Okay, they can mean moles, but they could also mean molecules, right? So that's why I just kind of skipped over that last slide since we already covered it. So an example of a molar ratio problem. Okay, determine the molar ratio of ammonia and nitrogen. Okay, so here's our ammonia, and here's our nitrogen right here. So it would be a 1:2 ratio. So I can use that molar ratio to determine a wide variety of different questions. The first type that we're going to look at is going to be molar ratio problems. Now, you've seen these in class already. Okay, that's when I'm giving you moles, and I want you to find moles for me. So, for example, let's say I had 2.50 moles of nitrogen, and I wanted to know the moles of ammonia I can make. Okay, so what I do, I would go with what I'm given, 2.50 moles of N2 over 1. Okay, if I look at my molar ratio, I note that there is 1 mole of nitrogen to every 2 moles of ammonia, right? So moles cancel out. I'm left with moles of ammonia. So my answer needs to have 3 sig figs. So my final answer here is 2.50 times 2 moles of ammonia over 1 times 1. My final answer here is going to be, let's see, 5.00 moles of ammonia. So I can make exactly 5 moles of ammonia from 2.5 moles of nitrogen. Okay? So another type of problem that I may give you is I'll give you the moles. Okay, so we still have that original 2.50 moles of N2, but now instead of finding out the moles of NH3, I want to find out the mass of NH3. Okay, and what we need to do is set up a problem where what's given 2.50 moles of Na or N2 over 1, right? And I got to get to the molar ratio just like I did before. 1 mole N2, 2 moles NH3. My apologies for that capital letter. Okay, but I'm not done yet because I want to find the mass. Okay, now the mass of a mole, which is the molar mass, okay, is for ammonia is 17.04. So I would go 1 mole of NH3 is going to form, or it's the same thing as 17.04 grams of NH3. Now, where did I get that? I got that straight off the periodic table. Okay, right? Nitrogen is equal to 14.01, and hydrogen is equal to 1.01. But in the equation for ammonia, this is times 1 and this is times 3. Oops, that should be a 1.01 times 3. 3.03 equal and plus 14.01, 17.04 grams per mole. Okay? So when you're writing how to get to where you need to go, you need to use, so we'll go ahead and do this. You need to go from moles of what's given to moles of your unknown is molar ratio. Okay? But to go from the moles of your unknown to the mass of your unknown, you need to use molar mass. Okay? So, and if you look, how many arrows do I have right here? I have 1 arrow, 2 arrows. How many steps dimensional analysis do I have? 1 step, 2 steps. Okay? At most, any of your stoichiometric problems are going to be 3. Okay? And we'll get to those here in a bit. Okay? So, doing my final problem, okay, I'm going to cancel out moles of ammonia, cancel out moles of N2. I'm left with grams of ammonia. And if I work my problem out here, I end up with 85.2 grams of ammonia. So what does that mean? That means that if I have 2.50 moles of nitrogen, I can make 85.2 grams of ammonia. And all I'm using is molar mass and molar ratio, 2 skills you already know how to do. All right? So let's take a look at the next one. Now, instead of going to mass, now I'm going to go to formula units. Now remember, a formula unit can be, it can be atoms, right? If it's an element, it can be molecules, if it's a covalent compound, or I could just say formula units for anything that is not an atom or a molecule. All right, and let's go ahead and stick with our original, right? 2.50 moles of nitrogen. But now I want to get to in this case, because ammonia is a molecule, I want to get to molecules of NH3. Okay? Now, if you notice, the bottom of my screen has not changed. Moles given, moles unknown. That's still my first step. This is still where I want to start. Okay, so I'm going to go with 2.50 moles of N2 over 1. And I'm going to go 1 mole of N2 and 2 moles of NH3, just like I have. This is my molar ratio. Molar ratio right here. That's what I just did. This arrow right here, number 1, this is step 1. First step. There we go. Now, I want to get to formula units from my moles. So I need moles on bottom. I'm going to go ahead and say 1 mole because it's the number that is appropriate. Okay, NH3. And if we recall, how many formula units are in a mole? And that'll bring us back to Avogadro's number, 6.02 times 10 to the 23rd. Okay, in this case, because the formula unit is ammonia, or the formula is ammonia, which is a molecule, I would say molecule NH3, right? Moles cancel out. Moles cancel out. I'm left with molecules of NH3. That's my unit. Okay? And so what you guys need to write down here, this is step 2. And on step 2, we used Avogadro's number, which is 6.02 times 10 to the 23rd. Okay? So if I was to do my problem out, my final answer is 3.01 times 10 to the 24th molecules of NH3. Okay? Now, again, this is a 2-step process because I have 2 arrows. Here's 1, here's 2. Okay, and I have a 2-step dimensional analysis. Okay, pretty simple. All right. Now, the next set of problems is going to give you mass instead of moles as you're given. Okay, so now instead of saying we had 2.5 moles of nitrogen, I'm going to say we have 2.50 grams of nitrogen. And I want to know, in this case, how many moles of NH3. So it's the same process that but you're kind of going backwards. Okay, take a wild guess on how many steps you're going to have. Okay, you're going to have 2 because here's 1 and here's 2. So you're going to have a 2-step dimensional analysis right here. You start with what you're given. Okay, start with what you're given. 2.50 grams of N2 over 1. Now, I can't go straight to my molar ratio because I'm not at moles yet. So I need to convert the nitrogen N2 into moles. Right? So I'm going to go with nitrogen 14.01. That would be 28.02 grams of nitrogen for every 1 mole of nitrogen. now that I'm at moles, I can use my molar ratio, which is 1 mole of nitrogen for every 2 moles of NH3, and then that gives me what I want, right? Because I want moles of ammonia, right? Moles of ammonia. That cancels out. I'm sorry, that cancels out, and that cancels out, okay? So, doing my math, I go 2.50 times 1 times 2 moles of NH3. Now remember, this molar ratio does not play an effect, or not play into account sig figs, all right? And remember, whenever you're doing a molar mass, you always want to go to the hundredths place, right? Always get to that hundredths place. Now, I'm going to have the same rule, which is I want your lowest number of sig figs to determine your final answer in sig figs. So even though the molar ratio doesn't have to play a part in your sig figs, the molar mass will. Okay, so I have 4 sig figs here, I have 3 sig figs here, so my final answer needs to be in 3 sig figs. Okay, so if I do this, I end up with 5.00 moles of ammonia. And then if I go here and go 1 times 28.02 times 1, okay, so 5 divided by 28.02, my final answer ends up being 0.178, okay, and then 4439, blah, blah, blah. But I'm not going to worry about that because I only want 3 sig figs, and that would be my 4th sig fig, or my 3rd sig fig. Okay, the next digit over would have been a 4, which was not enough to round that up to 0.179. So my final answer is 0.178 moles of NH3. All right? We'll do one more problem, and then we'll probably call it on this video. Okay, and I'll have to make another one later. But this is the meat and potatoes. This is the big guy right here. If I give you a mass, you need to be able to give me, if I give you a mass, you should be able to find a mass. Okay? So again, I'm going to go 2.50 grams of nitrogen gas. I want you to tell me the number of grams of ammonia I can make. Okay? So if you look, this is going to be a 3-step dimensional analysis. All right? Now, I'm going to go from mass to moles, which means I need to use molar mass. And then once I have the moles of the given, I need to get it to moles of the unknown, which is going to be using the molar ratio, right? And then if I'm going from moles to mass, it's the same thing as I'm going from mass to moles. I need to use the molar mass, all right? So let's go ahead and knock that problem out real quick. Okay, and this could be kind of small area right here. Okay, I'm going to have 2.50 grams of nitrogen over 1, and I want to get that to moles, right? So I'm going to use molar mass right here. So I have, what would that be, 28.02 grams of N2 for every 1 mole of N2. And then I use the molar mass, or the molar ratio, right here. All right, so 1 mole of N2 is for every 2 moles of NH3. And then I need to use the molar mass of ammonia to get to the mass of the ammonia. So I would go 1 mole of NH3, and that is 17.04 grams of NH3. Okay, the whole point is to make sure I need to get to my molar ratio. Okay, if I don't get to my molar ratio right here, I can't have the two masses talk to each other. They don't speak the same language because a mass of ammonia and a mass of nitrogen don't mass the same thing. So I need to get it to molar ratio so I can solve the problem. Okay, so moles of ammonia cancel out, moles of nitrogen cancel out, grams of nitrogen cancel out. I'm left with grams of ammonia, which is what I want. All right, if I do the math, my final answer with 3 sig figs is 3.04 grams of NH3. All right. Now, this right here should prepare you for tomorrow's worksheet. I will make a continuation of this video with the rest of these notes, and you can work on those types of problems when we get there. But if you understand that I need to get to molar ratio, and you know how to get to molar ratio, then you can go anywhere.